All right, just wanted to say thanks to all the early birds who have shown up. We will give other folks a minute or two to join, so bear with us for just another moment. All right, good afternoon, everyone. Thanks for joining. Go ahead and move here to the next slide. So I'd like to go ahead and introduce myself. My name is Jeremy Beck. I am the Business Development Manager for North America for Edge Software. And I'm here in our office in Daphne, Alabama with Douglas Turk, our Chief Technology Officer. For today's agenda, we are going to cover a live demo of precast modeling in Revit with Edge, which will cover topics like BIM content, piece marking, shop tickets, and more. We should have 10 to 15 minutes for QA at the end of the webinar, so please save your questions for the end. If we need to run over, we can, so maybe we can continue and answer questions after the hour is over. And of course, you can reach out afterwards for further discussions. This presentation will be recorded and made available on YouTube University for your further enjoyment. So before we jump into the demo, let me just quickly introduce our company, give you some background on who we are. So Edge Software was actually born out of PTAC Engineering, which has been in the precast concrete design and detailing business since 1991. Earlier this year, Beacon Software out of Toronto, Canada, purchased as Edge Software from PTAC Engineering to help us expand and scale the business. So we're very excited about that. All right, and so without further ado, I would like to go ahead and pass this over to Doug, who will be making the presentation for you, providing the demo. Doug, you have audio, everything good?
Yep, absolutely.
Perfect.
First off, like Jeremy said, thank you all for being here. We got a pretty good amount to cover here, so I'm going to be moving fairly quickly. But if you do have questions, we, like Jeremy said, are going to be addressing those at the end. So like the agenda says, we're going to go through kind of a couple of modeling steps, show how we can place precast product hardware into those products. In this case, it'll be mostly focusing on walls, but we will show placing beams and double T's, as well as we will flip over to a pre-built model to kind of show some of the ticketing features and some of the ways that you can leverage that for your workflow. You will notice that as we work through this, you'll be able to see where my pointer is with this indicator, and you'll be able to see keystrokes for hotkeys and such, so you can kind of follow along with what's going on. So first things first, we're going to build out a little wall box using these grids and levels that I've pre-prepared. In this case, we're going to be using the Edge insulated wall panel family. Excuse me. We're going to be using the Edge insulated wall panel family for the demonstration here, but this does also work with any other of our products. My goodness, I'm trying to talk and act and not working correctly. There we go. So we're going to first place this in, and then we're going to array it out over to the side. And then we're going to bring it over to this side and fill out this span of walls. We can also go ahead and bring this down here. Again, just kind of showing some things. Some of y'all might be already Revit users, so this might be pretty basic information. But for some of y'all who might be from an AutoCAD background or not immersed in kind of the 3D world here, some of this might be a little bit newer. This current interaction that I'm showing of arraying these out, of bringing in the panel by panel kind of approach, is something that we're working on in the near future, supplanting with an automatic panelization feature where you would actually model out the full span as a Revit wall and then use that utility to array, or well, not to array, but to split that into your selected edge wall family of choice. But for the time being, and for what's currently live in the product, this is kind of how we would go about that process of bringing these walls in. Again, pretty quick and easy, not too much manual adjustment here. Mostly we're just kind of bringing these into place to build this out. So once we have this done, we now find that we have a nice little box of walls in our model. So now we need to go in and we need to adjust the height of these because they're going to come in at the default, which is 20 feet. We want those a lot higher. And again, I've kind of gone through ahead of time and set up my levels at these various different spacings. These can be adjusted to whatever you need to do. We're not going to focus on that for this demo for the sake of time, but you're welcome to look into any Autodesk resources on how to do that in Revit, as well as our staff would be happy to answer any questions that you have about that. So to go ahead and bring this up to the proper height, we're going to use the shape handles that are built into this family. You'll notice that this has expanded our solid zone a bit, so we just need to correct that back. And then now that we have one of them correct, we can go ahead and select all of them and bring our height to the 4111 that we want it to be. Okay. So now that that's set up, we're going to go ahead and kind of show what to do with your corners. In this case, we're only going to do one, just again for the sake of time, since we got a lot to cover in the hour. But there are several ways that you could copy this out. You could easily delete the corners and bring what's done here once you're done, or you can mirror it out. There's a lot of different options. One thing I also want to highlight before we get into that is a little bit of the intelligence in the edge content. You'll notice that when we brought these in, it did properly apply a joint. That's actually handled via parameter on these wall families. Normally, you're going to interact with this nominal panel width to determine, when you're kind of spacing things out, figuring out where the panels need to go. But we do also have a parametric joint. So this is currently at 1/2 inch. If I were to convert this over to, let's say, something dramatic like 3 inches, you'll see that actually adjust for the entire model, as long as I've selected the entire model for that. So I'm going to go ahead and roll that back to 1/2 inch, but that's just another way of highlighting some of the intelligence that we've baked into all of the Edge families, and those are all available within the Edge product via the browser. Under the family menu, you just go in here, in this case, our wall panel insulated vertical face mix. But returning to the corner, so we're going to notice that these don't quite align. That's because the joint has been set up to exist at the extent, so we want to go ahead and turn that off. That's another parameter that we've built into this. You can just toggle it on or off as you need. And now you can see that we create a clean intersection at that corner. So now I'm going to bring in another one of our custom families, not that one. We're going to bring in the quark miter, and then we're just going to put that right here at the corner. And then we're going to mirror that out. Now I am at the top of foundation layer, so this is going to be too short right now, so we need to go and fix that. So we're going to return to our 3D view, find that, and let's actually go ahead and section box our corner, which is a Revit out of the box function, which will bring your view to match whatever you're trying to look at there. And we can see very easily what we're working with. Now, before we get into all of that, let's hop over to the north elevation. And we can actually, again, use those shape handles to pull this up to match the height that we want. Go ahead and do that. And now we should be good to go. We can come back here to our corner. We see that the void is poking up, so we just need to cut it from the correct walls. To do so, we're going to use one of the edge tools, the multi-void cutting utility. What this is going to let you do is select a group of voids and then click through all of the elements that you'd like them to cut. In this case, we're only selecting one, but you could use a selection group going into this. It's not just one by one. So we know that this one needs to cut this wall, its grout joint, and its placeholder beadboard to create the correct joint there. Likewise, we're going to do the same for this one. And I usually set up a hotkey for this tool, to be honest. I use it that much. But in this case, just to demonstrate, I'm going to click through, as with most of the edge tools in here. So something that you'll notice now is that we have this real clean intersection here at the corner. You can control a lot of things about this. If you select both of your quark miters, you can adjust the quark dimension, make that maybe 3 inches again. That's going to expand. You can also adjust the joint width in that diagonal space, again, highlighting that customizability of our content. So with that done, again, you could go around and copy that to the various corners in the model. In this case, we're not going to do that in the interest of time, but we are going to go ahead and move on. So the next thing that I want to place in is a column. Again, this is some of our content. We support a lot of different sizes for this, but we're just going to bring in the 24 by 24 right here in the middle. And then once again, we're going to hop over to our elevation view. Actually, I need to increase the scope on that so that we can see it. And then it doesn't seem to want to cooperate. All right, then we're just going to do it from here. So this is going to go to a height of 4111, just like our walls, to bring it up to the top. And then we can go ahead and there's really not much else to do here. I could do foundations. That is something else we support. We do have smooth joining foundations at the corners. I'll be showing that in the other model that I show off, but I'm not going to do the placement of it just in the interest of time. If you're interested in that, feel free to ask about it at the end or reach out if that's something that you want to see. But in the meantime, we will go ahead and move on to placing our inverted T-beams. And to clarify, you might see me using this BM shortcut. That's just to bring in a structural beam. With the way that the edge families are designed, they're all set up as structural framing elements, which if you are used to using Revit out of the box might be a little bit different. But what that allows us to do is it allows us to have a lot more controls over the parameters of these elements and not be beholden to the Revit out of the box wall workflow. So that is why we are treating everything as a structural beam, including walls and columns and such, as far as the Revit interface is concerned. Just kind of a quirk of how that whole system is going to behave. And actually, I appear to have placed that incorrectly. One moment. I want this at the intersection. And then I'm simply just hitting space to rotate that 90. And once again, I'll be using the grip handles to bring this in. Okay, and now we have our two beams placed at level 2. Nothing really to point out here aside from these are warpable families, which means that we can apply offsets to them to support warping. One of the tools in the Edge suite is the auto warping function. This is for parking garages and other structures where you would need to handle drainage or other kind of warping conditions. We support visualizing that warp as well as maintaining the flat for the purposes of ticketing. Again, that won't be covered in this webinar, but perhaps in a future one, and you're also more than welcome to reach out if you'd like to know more about that. But for now, all that we need to know is that we support battering on the ends of this. We support joints on the ends as well, somewhere in. It might actually be a type parameter on these. Yes, yeah, so you set up a certain joint based on the type of beam that you're bringing in. Again, all of that customizable intelligence, much like the other families we've shown so far. So next, we're going to go ahead and bring in our double T families. These we will use I think I want the 12 by 24 if I remember right. And we are going to place these at the center point of this wall. We're going to stretch it down to the correct point on the T-girder, again, using those shape handles, because we can. And then we're going to array this one just like we did the walls, 12 times 5. Oh, I clearly clicked incorrectly there. There we go. 12 times 5. And then we're going to see that this creates kind of an odd interaction here. So we can actually handle this with some of the parameters on the wall. And what we're going to do is we're going to look at this grid here. And in fact, we're trying to check the distance to the stem. It's hard to see right now because this is opaque. We can use the edge visibility tools to reduce that opacity so we can pull the dimension we want. And we're going to see this is 1 foot 10. Okay. So what we need to do is we need to put a joint or a flange edge offset on this. And I believe it's on the right-hand side, but we want to check real quick using the mark and op and out indicators, which will clearly show that it's on the right side. We can make this 1 foot 9 to handle the joint, and we see that that comfortably comes in. Now let's repeat the same thing for the other side. I did the same thing again. This is very specific about where you need to put your mouse to make that work. There we go. Okay. Likewise, we already know that this will be the left side because it's the mirror image. So we just need to make this 1 foot 9, and we have our double T's correct. Now we're going to go ahead and select these and copy them down to handle our other side. We're going to copy them from grid A to grid C. And then we are going to select them. And in order to get them into the right location, rotate them about here, 180 degrees. And now we have all of our double T's handled for level 2. So now what we need to do is bring these up to our other levels. As we saw earlier, we do have several different levels. And I'm realizing now why I couldn't see anything was also the opacity in this view. But we can now see where the beams and the double T's have come in on level 2. So we need to bring them up to our other levels. So let's go ahead and do that. So we're going to select all of our T's, all of our beams, and copy them. And then we're going to paste special and align to levels 3 and 4. And now when we go and look at this, let's look at it from the north, might be the easiest way to see. We're going to see that these have all come through on all of our different levels. If we look in the 3D view, we can see everything in there. And we've basically got our little parking garage put together. Now, what I want to show next is some of the different things that you can do as far as placing geometry modifications like voids and add-ons, as well as a small dip into some hardware and connections. So what we're going to do is we're going to go into our 3D view, and we're actually going to pick, let's see, where's our corner that has the good adjustment? Let's do the north side here. We're going to select all of these walls, and we're going to use the section box tool so that we can see just those walls, so we can focus on what we're working on. Now, what we're going to do is we're going to bring in some windows. This will be handled with another edge family, which is the void rectangular. Oops, hit the wrong button. And this is going to just be exactly what it says on the tin, a rectangular void that we can place wherever we need to. And it has parameters for controlling the dimensions so that we can create whatever we want. In this case, let's just kind of make a door here. Let's make something, I don't know, semi-reasonable. Let's make it 10 foot high by maybe, by maybe 6 foot wide. How about, maybe that's too big, but it'll work for the demonstration. And then I think we want to, yeah, I made it way too tall. That's on me. We'll make it 6 by 6. How about that? And then let's go ahead and pull this into place. It's going to line up cleanly. And then let's say that we maybe want to put some windows up here between each of the levels. So let's copy this up a couple times. And then these will go ahead and shrink down to maybe 3 by 3. And then maybe we want those on all of the panels. So we'll go ahead and array that out. 12 times 10. Okay, now we've got our windows in. Let's go ahead and maybe put a reveal across this. Again, this is another edge family. We're going to go ahead and place this on one of our sides. We'll square it up to the top at first, and then we'll bring it into where we actually want it in a moment. I'm realizing that might not be the right location. Ah, yes, because these, or I did not do the corner here. Let me just turn those joints off so that it comes together clean. And then actually it's already correct, so that's good. Okay, and now what we can actually do here is if we hop over to our north elevation and look at this, we'll see our shape handles come back, and we can just grab and stretch this all the way down. And then we can actually move it down to wherever we want. So in this case, let's say that we maybe want to bring this down to here to make it intersect nicely with this window. And then maybe we want another one right there. Okay. Oops, did that wrong. Right down. There we go. Okay. Now, what we can do now that we have these voids kind of placed in here is we can go ahead and cut them. So we're going to go ahead and select all of our rectangular openings. Oops. And then we're going to go ahead and select all of our reveals. And then we're going to run the tool I was talking about before, the multi-void cutting. And then we're just going to click on down the line. And I'm realizing now that I probably didn't fix the depth on these. Yep. So we're going to actually hold on a second on that. And then we're going to select these, make their depth 14 inches because we're dealing with the 14-inch panel. And now we'll do that part. Yeah, and we should see these cuts come in nicely. You will notice that the insulation's still peeking through, but we can fix that. Just a moment. And that insulation that's already in there is kind of a placeholder foam family that's built into our insulated wall panel. We do have tools for replacing that with actual proper insulation panels. We may or may not get to that today, depending on how long we take to get through the rest of this. But I definitely think that if we do another one of these kind of educational webinars, that'll probably be a topic for then. So as we can see here, we now have our row of panels with some nice cuts, some reveals cut through them. Again, because it's model-based, this reveal's nice and lined up across the board. You won't have to be fighting that later on when you're running shop tickets. So again, we've kind of created some nice void-related geometric changes here. So now let's go ahead and look at the add-on side of things. So we're going to go ahead and bring in the Edge Corbel family, which is in here. We're going to place this on the face, simply square this up to the stems of our double T's, and then let's just offset it down a little bit for the bearing pads, and then we will copy this across. We know that we want it to be 6 foot, whoops. We want it to be 6 foot times 20. That should be nice and squared up to all of our double T's. And then we can just go ahead and copy these down using this point on the stems as a reference. And now those should all be nice and lined up for our span of walls. Again, we're only doing this for one span of walls, but you could very easily copy these things around to the other spans. In the interest of time, we're just focusing on these. So we've got our corbels on this side. And then let's go ahead and add some cornices to the other side. And maybe we'll just do kind of any one of these panels. Maybe we'll do this one. So we're going to go ahead and again grab one of our families. I believe this one I might have to go to the Edge browser for. So we're going to go down here, pull in the add-on cornice. And that will now be loaded into the family. If I can find it. Ah, there we go. It was unhappy because I was in there. But now it's loaded into the family. So we can go ahead and grab that. And then let's just square it up to the top left of our panel. hop over to the north elevation, find it, and again, use our grip handles to get that perfectly squared up to how our panel is. Okay. So now we've kind of got, and obviously you can do a lot of different things here. In this case, we're just going to use this as an example. So now we've got some nice add-ons on this side, some add-ons on this side, but we need to make sure that those correctly adjust the weight of our panel. So we're going to look at a parameter on here, if I can find it, called member volume cast. So you'll notice that that's blank right now. That's because we haven't set those volumes yet, or set those weights or anything at this point in the model. That's where a very important edge tool called the add-on hosting updater comes in. And what this is going to do is it's actually going to analyze not only the add-ons in the model, but all of the pieces, look for any add-ons that are on them, and then update the materials of those add-ons to match the face that they're hosted to and join them to the wall that they're hosted to as well. So in this case, this cornice is hanging on our architectural face. So it's going to pull in the architectural material from this side. And if we actually look on here, we'll see architectural precast concrete, whereas the corbels are on the structural face, so they're getting the regular gray precast concrete. Additionally, you might have noticed that the member volume cast and weight cast have updated to reflect the add-ons there, and we can see the variation in that if we look at these other panels that only have the corbel. So again, that's a super basic version of the modeling steps. There's a lot more that we can do with it, but we're going to kind of fast forward into, well, actually, I apologize. We're going to do one more thing. We're going to show connections real quick, and then we'll fast forward into the other model where some of this is kind of already done. So to show how we would add some connections into here, we're going to hop to one of these levels that has double T's, and we're going to start with the wall to double T connection. In fact, that's probably the one that we will show this time. There are lots of different connections that we've built over the years, custom ones, standard ones. Some are provided via the Edge browser. Some we've kind of developed over time. So let's go ahead and look at the wall to double T connection. And you'll notice that this is set up in a very specific way where when I'm going to place it, it's showing the face of the plate that's going to go into the wall. So what we actually need to do here, whoops, I did that wrong. There we go. What we need to do here is rotate it to the correct side and then bring it in to our wall face. And then we'll see that that's nicely aligned. And we'll see that it is, actually, I apologize. I did that incorrectly. What I need to do is I need to tell it to place on the work plane, level 2. Show why in a moment. But we can go ahead and place that there, and we'll notice that it correctly is half embedded in the double T. This plate's part of the wall, this plate's part of the T, and everything's squared up. Now, what you may want to do here, if you find that this isn't aligned like it is here, we can go ahead and do that and then grip handle it back, and that quickly resolves the joint. Now, another thing to note is that this is actually built as a nested family, so the plate in the wall will be treated as an independent element of the plate in the T for the purposes of ticketing. So you're not going to have to intentionally hide anything or remove anything. It's got intelligence built into it to know where each is supposed to go. So now that we have that one correct, we're going to go ahead and array that out at 6 feet times 20 to hit all of our double T's. We'll notice that they've all come in nicely. We can also go ahead and mirror those out to the bottom to get those put in. And then we can select all of them, copy them, and then special paste to levels 3 and 4. And we now have wall to double T connections on all of our levels. Again, we do also have connections for T-girder to double T to double T, wall to wall, whatever connections you need. We've probably built something at some point. Some of that's in the library. Some of them might be custom, but we're happy to help with setting that up. All right, so now that we've kind of shown how to do all of that, let's go ahead and hop over to the other model where we're going to demonstrate ticketing and a couple of other edge features that are relevant to that process in the context of a model that looks very, very similar to this. So let's go ahead and close all of this out and hop over to this one. So as mentioned before, this was based off of a very, very similar recipe. insulated wall panels around. We kind of put some various different openings here for flavor, but we did also go ahead and panelize all of the insulation. If any of y'all were on the webinar for release 12 of Edge, I'm not sure if there are any Edge current Edge customers on this call at the moment, but this is the model that came from that, along with some additional embellishments. So what we're going to focus on is these 4 panels here that I've kind of gone through and added some architectural finishes to, added some reinforcement to, added some plates to, and kind of show how these guys are going to react to ticketing in the Edge workflow. So first things first, and I actually have already done this ahead of time, but it's very important to do this if you're actually doing this live, is to run the add-on hosting updater. This is always going to be your first step. You want to make sure that this has been run so that all of your weights, all of your hosting, all of those things are correct. So we're going to go ahead and run that first. Now that that's done, we want to go ahead and start creating assemblies. So first we're going to do this one. You can do multiple assembly creations at once. In this case, I'm going to start with this one, and then I'll kind of show some of our tools which are based more around copying features of assemblies over to others. So we'll kind of show the others as a package deal. This prompt will always come up whenever you run the assembly creation tool. This allows you to check for interference between plates and reinforcement. Just as a quick sanity check to make sure nothing got placed incorrectly. I'm going to run this. I'm honestly not sure if there are intersections in this model or not. There appear to not be, so we're good to go. Okay, so now we're going to need to set our orientation of this assembly. So by default, if you've used Revit out of the box, you'll know that this assembly is going to be placed at the family origin, aligned to how that family works. We don't want that. We actually want this to reflect the casting position of this piece. So we're going to set the top as cast face by running this utility. With this, we're going to go ahead and pick which face we have as the top. In this case, it'll be the structural side. We're going to pick the left side, and we're going to pick the bottom side, and then it's going to tell us very quickly what our top axis is, our front axis, and our left to right axis are. Now that we have that in place, in this case, we're going to make it very simple. We've already created ticketing templates. There is a workflow involved in that where you need to set up a pattern ticket, lay out your views, lay out your schedules, get everything prepped ahead of time, and save that template. But once that template's saved, you can use it over and over again within your organization. And it does allow for multiple manufacturers if you need to support several different producers. Again, in this case, in the interest of time, I did go through and set up my ticket templates ahead of time. And I've actually set up 3 different sheets to show a few different things that you can do. So we're going to go ahead and run the auto ticket generation tool, select multiple templates, and select sheet 1, 2, and 3 here. It's going to pick a scale based on what was set up in those templates, but you can override that if you choose to do so. In this case, I won't. Same for the title block. That will be suggested based on what was in the ticket template, but you can choose to override that if you wish to do so. Another feature that we're not necessarily going to get into here is there is a dimension and callout customization. You can choose if you don't want to see dimensions to certain elements in the piece or don't want to see callouts. This can also be controlled via parameters on those families. Again, you can feel free to look into some of our documentation or reach out if you have questions about that, but it's all fairly straightforward, and it's mostly based on which views you do or do not want to see those dimensions in, like top, bottom, front, back, left, right, etc. So let's go ahead and populate the tickets. Take it just a moment to run through. But we will end up with this ticket. So what this warning's saying, this is an important aspect of auto ticket generation, is that the way that our dimensioning functions is we are going to try and dimension to a specific type of reference line that we provide content that has, called an edge dim line. Usually those are going to be placed at the family origin, and in fact we have a tool that will update your families automatically to include these. But if you go into those families, you can customize the location that those edge dimension lines come in at. Additionally, in a future version of Edge, we're currently working on a prototype where we can pull 2 centerline references rather than edge dim lines, but these do provide more flexibility in what portion of your elements you want to look at. In this case, it's telling me my solid zones don't have edge dim lines. That's intentional because I don't want to dimension to them. So what we see here now is a more or less complete ticket. It's also placed my schedules that weren't necessarily prescribed on the template, but that we might want off to the side. You can delete those if you're not interested. That was actually the insulation one, which we'll see on a different sheet. But you can see in here that we've essentially pulled dimensions to all of the different pieces of hardware in this piece, as well as pulled callouts to each unique one. These are also split up based on the location of the element in the form, TIF indicating top in form, BIF indicating bottom in form. And you can see that on both the callouts and on the append strings of the dimensions. Additionally, we do apply upsetting to these if the text doesn't fit. We do our best to kind of format it in a way where it's readable. Sometimes that readability comes at the expense of aesthetic, as you'll see on the reinforcement page, but that is also something that we are working on enhancing that algorithm, and that's something that we're always trying to improve is the overall product that this generates. In addition to these views coming through, this top view and this side view, we have also created a parts list indicating counts, marks, and descriptions of the various pieces of hardware in the assembly. These are also set up through a templating system, which you configure via your user settings. In fact, there are several different user settings that apply to ticketing where you can do things such as configure which dimension styles you want to use, as well as which callout families, how you want the append strings to read out, whether there's a threshold under which you don't want to see dimensions pulled, and also how you want to see your overall contour and block out dimensions appearing. These also apply to our other ticket tools, but we're going to focus on auto ticket and clone ticket today. These others you can feel free to read about or reach out and ask about if you have questions. There are also the settings for the bill of materials, which I was getting at, is you can set up a name for your schedule template. You simply set that up, and I'll go to it in a moment. You simply set that up in your project level, and then you set what the name is, and it will copy that down to the assembly and then filter based on the assembly that it's copying down to. Additionally, again, just to kind of run through all of these, there's the title block populator settings. This is going to control which parameters get read out into your title block. In this case, I kind of just took a title block off the shelf, so it's not very well instrumented against the settings that I have in here, but you can choose to map any shared parameter that's applied to a piece to a shared parameter that's applied to sheets, and our tool will actually copy whatever value is in here into here so that you can read it out via labels on that title block. In this case, you can see where the length, the width, and the weight came through, as well as the project name, and so on and so on. That's the majority of the ticket settings as far as the ticketing tools go. So let's go ahead and look at some of these other sheets. So this one is designed to be an insulation view. Again, we have this parts list off to the side. We don't need it for this view. What you're going to see in here, and you'll have to forgive me, I actually didn't update the insulation family prior to this, but you could set up your insulation family to have dimension lines, so that would get dimension 2. In this case, I used an older version. I apologize, so that dimension is not automatically pulled, but it's very simple to go through and update that family to work correctly. But we can see the insulations visible here. So let's say we want to go in and tag this based on the insulation mark. And what we have for the insulation mark is actually an insulation marking utility, where we're going to look at all of the insulation in your model and name it based on its likeness to other pieces in that model. So in this case, I've already gone ahead and run that ahead of time, and that's what this schedule is reading out. So it's saying that we have 2 number 2 sheets of insulation, as well as 1 of each of these different unique pieces, which again was created by the various cuts and depressions that are featured in here. If you're more interested in insulation, like I said, there's a lot of different utilities that we provide for that as well, including a drawing tool where you can actually see that insulation rendered as a drafting view in your project at both the project level and the assembly level. In fact, we can actually show the assembly level for this piece. That might be interesting to see. Before we do that, though, I do want to show how easy it is to actually tag all of these pieces of insulation if you want to see that mark in the drawing. So I'm going to go ahead and select all of the insulation in this piece and then go through to annotate, and we've set up an insulation mark tag. And if we go ahead and run that, we'll actually see all of this insulation called out by name in our drawing, so we can tell very easily what's what. And then, like I mentioned before, we can actually come in here to the insulation tools, run the insulation drawing for assembly, tell it we want to do it for that one, and then finish. And let's place that on sheet number 2 for this assembly. Draw. And what we'll see, again, it doesn't really know what to do as far as fitting it onto the sheet, but it's going to hand you the drawings and then you can space these out however you see fit. And this is going to show the dimensions of the insulation, any recesses that are cut in it, as well as the mark of the piece that you're looking at. So let's just say we're kind of looking at our space. We can probably fit these right here. You know, again, you kind of have to move these around to fit your sheet. In this case, we've kind of used a pretty small title block, so I'm not going to waste too much time designing this correctly. But the point is that you can actually pull these drawings around the sheet as you see fit. In this case, I'm going to delete it because it's poking out pretty far. But you can also change the scale on that if it's coming through too big. You can kind of mess with it to get what you want. But the point is that it's going to read out those dimensional informations on the different sheets. Okay, so that's probably it for the insulation sheet. Let's move on to the reinforcement sheet. So this one is reading out the location of strand, as well as the location of the various straight bars in the panel. So what you're going to see here is actually dimensions pulled to those, as well as counts. You're also going to notice that those bars have been named according to your rebar settings. Again, this is kind of another edge feature, possibly for another webinar, but we do have automatic naming for bars, including straight bars. In this case, it will prefix with S, show the bar size, and then show the bar length in feet and inches. And that does also have metric variance if that is needed for your use case. But here we can see, you know, S4 111, S4 0311, again, these are marked based on the length of those straight bars. We see how many there are in here via our append string, and we see their spacings. You'll notice that they have kind of these ugly upsets right now. This is actually something that we're working on for the very next Edge release to actually combine a quality formula with upsetting. There were some tech limitations in Revit that kept us from doing that in the past, but we've come up with some solutions that we think will solve that problem going forward. Yeah, so that kind of shows this. Again, you can sort of see the strand from the top view here. You can also see the straight bars. Again, this is just kind of showing some of the different kinds of views we can generate with regards to all of that. And this, the way that we're showing different things is via view templates set up through Revit. You can customize those with all of the features that are present in out-of-the-box Revit, and our ticket templating system will actually save that view template information to the ticket template as well. So all of that's set up ahead of time. Okay, so next I'm going to kind of show how you might take this intelligence and copy it over to other pieces. So it's always been the design philosophy of AutoTicket that this is sort of your first step when creating a ticket. It's not always going to create something that's perfect on the first go round. Maybe it dimensions something that you didn't want. Maybe it calls out something that you didn't want. Maybe you need to add some annotations. With our new copy or clone ticket feature, we are attempting to let you take those changes that you make to what we generate and actually copy them out. So let's say I wanted to go in here, and that's a foolish example because you know I wouldn't necessarily be doing that. But let's say that I wanted to put some annotations in here. Let's say I wanted a box here, and then I wanted to have some kind of text, you know, some text note. Maybe I wanted to come in and add some kind of symbol, and I'm not sure if I actually have any in here, but that's not really what I want. Yeah, so maybe we just have some, again, this is just kind of nonsense, but just to prove the point of what you can actually add to this. Any kind of symbol, any kind of text note, any legends that you may have, you could add to this view. Let's say that I don't care to see my P2s dimensioned on this side, or maybe I don't care to see my Corbels dimensioned over here. I can delete those. Then let's just shift this into place, then shift this down to compensate as well. And then maybe I just don't want any of these on the bottom for some reason. Okay, so again, I've just made some arbitrary changes to this ticket. Now I'm going to go through and I'm going to copy that to some like pieces. So let's go back to our 3D view here. And like I mentioned before, I only assembled this one so far, but I know for a fact that I want these three done almost the same way. So let's just go ahead and run our assembly creation tools on these three pieces. It's going to do a solid interference check to figure out what all needs to be brought into those pieces. In this case, I can check for intersections. Again, I'm not sure if I have any or not. Yeah, so in this case, it's saying your strand is intersecting this plate over here. You can actually pull this up and see what's going on. For my purposes right now, I don't care, but you could go in, disassemble it, fix the issue, and then run the tool again. So I'm just going to tell it to continue. And then let's go through here and we're going to, again, try to get top as cast correct, but we know we did it already for this one. So we're just going to copy from this over to these three, and we're going to see that the coordinate system came through the same way. So top as cast is done. And we're also going to notice that this one's not reinforced yet. So one tool that we do have to make the process of reinforcing these panels a little bit easier, it's fairly rudimentary, but it does save some time for very similar panels, is the copy reinforcing tool. So we'll run this. We'll say that we want to copy reinforcing from this panel to this panel, and we're going to see it come through. So what I meant by saying that it's kind of rudimentary is that it's just going to copy it directly from what was in that assembly. So in this case, these are going to come through long. They're going to be poking through this opening. These are going to come through short. You'd probably have to switch these. So there's a little bit of cleanup to be done, but it saves you the time for all of these straight bars, and you can just simply come in and clean these up at your leisure. In this case, I'm going to leave it how it is just for the sake of time, but I did want to illustrate that to make sure you understand some of the benefits and some of the limitations of that tool. All right, so now I have all of my assemblies built out. So let's go ahead and say we want to clone our ticket configuration from the one that we set up from IWP007, which is this piece, over to these three pieces. And we can run that. We know that our bills of materials are aligned to the bottom and stacked, so we could go ahead and hit bottom to do that for all of them. And then click through. It'll take it a minute because it's analyzing all of the dimensions, all of the annotations, all of those things that I pointed out and copying them over to the other piece, or pieces rather. Give it just a moment. Perfect. And now we can hop over here and take a look at what it made. So this is our sheet one. Again, we're seeing those annotations that we brought in coming through. We're seeing these different tags coming through in the same location that they were. Any matching hardware is dimensioned in the same way as it was in the source, but counts are updated to reflect the piece that we copied to. So there is intelligence behind these to make sure that any text that's associated with a dimension is being brought through and updated to what we're actually bringing it to. Likewise, you can see that the dimensions are gone from the bottom that would have been generated. Again, these text notes, all this stuff comes through. There are some elements that were in the source that are not in the target, which is why there's gaps in the dimension lines here. That's intentional so that we're not just copying bad data to that model. All of this is linked to the actual piece that you're ticketing, and that should be reflected in the dimensions and the callouts. Likewise, the schedule has adjusted to accommodate whatever's going on with the target ticket that we've cloned to. So obviously these piece counts are a lot lower than they were in our IWP007. We can also go ahead and take a quick look through here. We see that the insulation annotations have been brought through. There's some weirdness here because of the fact that I think maybe this sheet of insulation was weirdly aligned. You may want to go through and kind of clean this up yourself, but you can take a look here and confirm against the schedule that everything's correct. So that should be all good. And then, oh, that's on me. I forgot to run assembly creation when I copied reinforcing. So that's why that didn't copy, but we'll see it on the other ones. That was my mistake. If I had run assembly creation, these would be pulled in and then reflected on the ticket. As it stands, they just are kind of present, but not showing. So let's hop over to IWP005. Again, quickly kind of step through these. We see the same thing on sheet 1, sheet 2, sheet 3. This one obviously has reinforcing as shown before. Again, you're going to see this gigantic upset, which is something that we are working on again with that equality formula sitting side by side with upsetting. Lastly, we'll go on to IWP 006 just to finish it out. We'll see the same kind of things. Just kind of clicking through here. And we can see that it was correctly cloned. One thing that I do want to cover real quick with the last bit of time that I have left, because I did forget to show this at the beginning. Actually, before I get to that, I do want to show one other tool here, the ticket manager. So what this is used for is actually following the pieces in your model through their life cycle. So this is going to look at all of your like named control marks. You can click through them, kind of see where they are in the model, as well as you can see the status of that element. So in this case, I have assembled IWP 001, and let's actually use a different one here. Let's use 007. So I've assembled this guy, so that automatically happened. It knows that this is the assembled one. It says that I haven't reinforced it because we don't want it automatically guessing at what you have and haven't done. If I want to tell it that I've reinforced it, I can select the assembly, hop over to my edge menu and mark the assembly as reinforced, and then hop over to the ticket manager, and now I see when that happened and who did it. Additionally, we can see when the ticket was created. Again, I used auto ticket a minute ago, so it automatically wrote that date and that username. Detailed, we have another utility for setting that up. I'm not necessarily going to show all of these. And release. So with this, you can actually follow the piece's life cycle. You can know which ones are done. You can set them as on hold. You can write a comment in here if you need to for some reason. And this just kind of lets you track the project lifecycle. Additionally, we have exports to text file, CSV, and Excel to pull this information out of the model if you want to use that for some kind of organization-wide reporting. That is also available through that. Again, just wanted to kind of highlight that. And then the other feature that I wanted to highlight that I accidentally missed at the beginning, my apologies, is the mark verification utility. This is a very big and important one. What this actually will do, and in this case, yeah, we're gonna kind of roll this back just a little bit. So we're gonna unassemble these and pretend that this is a fresh model. And let's run mark verification initial. So what this is going to let you do is it's going to, even before you've done any assemblies, before you've done any reinforcing, at any stage in the model, you can actually name your pieces based on these various different comparisons. Those comparisons are going to include properties of the panel itself, material volumes, add-on and plate locations and types, and actual geometric comparison between the panels. This all also has tolerances that are supported via user settings, which I'll show in just a moment, to control exactly what level of comparison you actually want to perform. In this case, we're going to run all of the comparisons with, I believe, the default tolerances, but we'll take a look in just a moment. So while this is running, it's going to be checking all of those parameters, checking all of the locations of those plates, volumes, all that stuff, and then creating buckets and assigning these to those buckets, and then assigning a control mark naming scheme to those as well. That naming scheme is also configured in settings, and we'll take a look at that in just a moment. So here we see that all of our double T's, except for the ones on the outside where we changed the left and right conditions, ended up as DTO1. The ones on the outsides ended up as DTO2. This does allow rotation of the piece, just because those marks should be the same, because they can be cast to be the same. It will warn if your embeds are rotated, since it's probably fine, but it just lets the user know that there's something that needs to be checked there. But we can see where this is kind of grouping these based on their likeness. You can step through and see it be selected in Revit to confirm that you agree with the groupings that were made. Oh, whoops. Accidentally got out of the window there. There we go. You can see these going through. You can step through. You can actually investigate the specific ones in that group if you want to know which one's which. If you disagree with the name it gave you, you can actually say, I want this to be called something else. Let's make it IWP 9999, and you can save that, and it'll override the group name. And then when you click apply, that's going to actually go ahead and write that to all of these elements. Additionally, we have the mark verification existing tool, which is going to look at the namings that you've already applied and make sure that everything actually does match everything of its same name. So we'll go ahead and run that real quick. Everything should pass because we just ran initial. But if it didn't pass, it would give you breakdowns of exactly what was different, what was wrong, what you might need to change to make your grouping correct. So again, everything passes. Some of them have warnings because of rotated plates, which is probably due to these connections. I believe I mirrored them across the axis earlier, so it's saying, this is probably right, but just make sure. And you can see if there were any of these that had problems, you can actually see those comparisons and exactly what failed and where. In this case, because everything passes, you can't really do that because nothing failed. But suffice it to say, that's how that would behave. So let's go ahead and look at the settings for that real quick, and then I will wrap up and we can move to the questions. I know, again, I kind of ran up against time here, but I did want to cover this feature because I do think it's very important. So this is where you choose how you want to name these. It's based off of which kind of product it is. You can apply a prefix and suffix based on that. You can choose whether you want your incrementer to be numerical or alphabetical. And if you choose it to be numerical, you can choose what number it starts with, and if you want leading zeros, and so on and so on. This is the tolerance settings. These blanks, the defaults are documented in the help file. It won't tell you those from this window, but there are defaults that it's going to use. It's not just 0 for all of these, but you can override them at your convenience. So I'm going to go ahead and stop talking, and we can kind of move on to the next phase of this with some Q&A, some discussion, whatever else we need here.
Excellent, Doug. Thank you very much. And obviously, there are a lot of tools in the Edge toolbar there that you were going through, and we've only gone through just a few in terms of like auto ticket generator, clone ticket, some piece marking. You showed us multi-void cutting, some add-on hosting. What other tools would you say, if we had another half an hour, what other tools would you say would be really great to show if we had the time?
Oh, I mean, all of them, right? But no, I mean, I think there's a lot of different tools to cover a lot of different conditions that you might do. Like I mentioned, the insulation tools are extremely comprehensive. We have the warping tools with warp parameter copier, auto warping, all of these different things to support these kind of parking decks to handle those drainage conditions. That's going to not only warp the pieces, but also show visualizations of how your hardware moves with those conditions. We have things like the control number incrementer if you need to track kind of all the different control numbers within a mark. We have rebar marking utilities. We have erection sequencing utilities for production. We have just a whole lot of different tools for a lot of different use cases. And again, I'm not sure exactly when it would be, but I do foresee that we might try and turn this webinar into kind of a series and cover some of those other more specific slices. This is just kind of as Jeremy put it, kind of dipping our toes into it, kind of seeing that 0 to ticketing process.
Excellent, thank you. So if there are any questions from folks out there, you can add them online, or at least you should be able to add them online there or raise your hand, and I can hopefully enable you to speak. Hopefully that works for everybody. Doug, and while we're waiting for additional questions, you kind of touched on some upcoming features. Can you just elaborate a little bit more on what's on the roadmap?
Sure, yeah. I mean, probably our biggest things that we're excited about coming up in the immediate future are, as I mentioned before, a lot of these enhancements to auto ticket and clone ticket. A lot of those have come directly from suggestions from our users, from people from the PTAC bunch who we're still working very closely with. Just kind of looking at this, this is a feature that's been around for a good chunk of Edge's lifetime. But we really have been iterating on it and trying to make it more and more perfect as time goes on. So we really feel like some of the things we're doing for that are a big jump forward. Additionally, like I mentioned before, we have the auto panelization coming that I think will simplify a lot of the tedious tasks of pulling those precast panels in one by one to the model.
Okay. And we got some additional questions. And maybe this would be difficult to answer in this short amount of time, but one question came in about how is reinforcing added to the panels and other precast
Sure.
elements?
Yeah, just to make a real simple demonstration of it, just for the sake of showing something here. Um, you know, right now, we don't have much automation on that. That is something that we're sort of playing with, different schemes for automating reinforcement placement. But right now, our rebar is also a loadable family. Much like I mentioned with the products that we do, we don't necessarily use the Revit implementation of rebar. There's some limitations to that that we just weren't really comfortable with accepting, especially when it comes to rebar marking and piece or bar by bar attributes. Um, Revit really wants you to kind of, maybe I'm looking at this wrong. I'll just do it from the 3D. Um, Revit really wants you to do certain things and treat the bars kind of as groups, whereas we prefer to be able to kind of handle them as individual entities. So that's kind of why we went with that approach. However, we have seen and acknowledged that Revit has come a long way with their rebar, and we are kind of working in the laboratory on different opportunities to match kind of what they're doing with some automated rebar placement. So again, this is a super simple version of what you might do, but as you might have seen, you kind of host the rebar to the face that the cover's on, bring it in, stretch it to the correct locations. We do also have bent bars. I'm realizing now, I think we've only shown um, straight bars, but rest assured we do have bent bars. I'm not going to bring them in right now because that would take some time, and I do see some other questions coming in. But for now, just understand that you place it kind of bar by bar on the face that the rebar or the reinforcement cover would be, and then bring it to exactly the location that you want. And leg
All
lengths
right.
and such are handled with parameters. Yep.
Okay, thank you. Yeah, so there's definitely an extended version of this that we could do on reinforcing. So I had some other questions about double T's. It says, is double T with a camber?
Yes. That you'll have to forgive me because I'm not extremely well versed in how the family's put together, but I know that you can support camber via we either have a different family for it or it's handled via some of these parameters built into that family. I can get back to you on the details with that, or maybe even on the documentation for the family itself to clarify that, but that is something that you can support.
Hmm. And how does that relate to, and can you present the auto warping tool?
Sure. Yeah. Let me
Do you happen to have a
hop
parking
over
garage
here.
bay available that you could warp?
Somewhere I have one. Let me find that real quick. Might be this model. Let me see. Yeah. So this is obviously real. Scrappy is how we'll put it nicely. We kind of took, I don't know if it was something real or kind of a development model and sort of butchered it up here to create an indication. So the way that the auto warping works is that you actually place these little spot elevation elements, and then those dictate the heights that will be found at those corners. And then we use your horizontal elements in the field to figure out the direction of warp. And then we actually apply that warp to meet the spot elevations you placed. So if we go in here and we run our auto warping tool for the whole model, because that's all there is, you will see that we kind of got this after image, right? And that's because we offer visibility options for flat and warped or both. So let's go ahead and turn off the flat so we can see the warped condition. You'll notice that the T's moved, the beams moved. I'm actually going to turn off these mark and op indicators because they're kind of distracting. And you'll notice that the connections also have shifted to match that warp. So what that's actually doing is this is generating, it's not going to double up your schedules because you might look at this and be like, oh my goodness, it duplicated everything. It's actually creating these direct shape elements just to reflect the geometry of that without doubling everything up. And you can toggle obviously between the flat and the warped, and tickets will always be based off of the flat state.
Excellent. Okay.
Okay.
Thank you. And it
Okay.
doesn't look like we have any additional
I
questions, and we're
see. I
just
see one in the Q&A section actually
oh,
from
there.
Byron about using ticketing, combining
All right.
linear and ordinate dimensions for different elements. So yes, short answer yes. So auto ticket. Let me hop back over to this one real quick. So short answer yes. Auto ticket will not do that. Auto ticket, you're going to tell it up front, I want my overall dimensions to be this and all of my other ones to be this. However, if you go into that original ticket and modify one of those to be an ordinate for this element or that, clone ticket will understand that you did that for that ticket and it will copy that dimension style over to the ticket you're cloning to. So it's supported with clone ticket, but not with auto because we don't currently have that level of customization per hardware mark at the auto ticket level. And then I also see a question from Shannon here asking, other than the training package, how do we handle ongoing support? So the training is the 1 week, 5-day crash course in as much Revit and Edge knowledge as we can impart. Ongoing support beyond that, we do have a help desk email, edgesupport@ptac.com. We have several people on the development staff who can answer any kind of tech support questions you might have there. Additionally, most of us are happy to field emails to our work emails as well. If you just kind of have broad questions about Edge, we can usually find, either we can handle it over email or handle it on a quick call or whatever you may need. But the short answer to that is that we do have a help desk system for handling support tickets.
Excellent. I think that might be it. Right. So excellent. Great. Wonderful. I think if I'm just going to take over this screen real quick here and just show contact information. Looks like I got to swip that out. Okay. Hopefully you can see that. So yeah, thanks for joining everybody. Obviously you can go to our website and get a little bit more information. That website is being updated, hopefully very, very soon. But we've also got tips and tricks and so forth on our blog, as well as a lot of helpful videos. Some of those videos are actually clips from the Edge browser that Doug was showing, where he was pulling that content out. You can actually get tutorials and helpful files right there within Revit in the Edge browser. But if you've got any other questions, obviously you can reach out to me. My number and email are right there, and of course you would have that on the invitation from me on this webinar. So thank you all for attending, and we will make this recording available to you all here in the next few hours. We'll put that out on YouTube so you can share it with others. And we look forward to seeing you on the next call.
Yeah, thanks so much, guys, for attending. I really appreciate it.
Thank you. Bye-bye.